Welcome back to Text Transformation with Red. Today, what we will be doing, if we have enough time, is we will be adding the rules for parsing the markup for inserting an image into our document. And if we have enough time, we may look at inserting a block of formatted, pre-formatted text, something like code. Sometimes you see in a web page or a document a snippet of code, and it's typically using a different font, typically a mono font, sometimes shaded in with a light gray background or something like that. So this is what this second piece here is. The first one is the syntax for image. But before we do that, what I would like to do is is to write a couple functions that will give you an idea of where we are going with this. So right now, this parse function is essentially the front end of our program, and I guess you can compare it to a scanner slash parser combined in one. And what this is doing is it's going through our input line by line, looking for patterns. When it matches a pattern, we tell it to do something. In this case, we are creating an intermediate representation of our data. And in the Red programming language, code is data and data is code. There's no difference between them. And as I mentioned in the first few videos, is that at the end of the parsing process, we'll have a data structure, a data block, which looks kind of similar to an abstract syntax tree. But in our case, it is what I like to refer to as an executable syntax tree, because apart from being a block of data, it's also code, which we will execute. And I'd like to show you a little bit what this is meant to look like. So what I'm going to do is I'm going to create a function. Well, first of all, if you recall from our previous exercises, what we've been doing is incrementally building this data structure that looks like this, a data block that looks like this, H1 with a heading, and then maybe a H2 with a heading, and then maybe a third level heading that is unnumbered with a heading. All right, you remember this? So what I'm going to do now is to give you a taste of how all the pieces are meant to be working together as we build this. Is I'm going to create a function. I'm going to pass it a heading. And essentially what this is going to do is I'm going to have it take this heading and add a couple tags to it. So specifically H1 and also a closing tag. And in between that, sandwiched between that, is going to be the heading that we passed in. And all this is going to be wrapped up in a reduce function, or a call to reduce. And in red, spacing really doesn't matter. We could have written this all on one line. Like this to save a bit of space. Because if you recall, actually I don't think I spoke about the reduce function. I know I talked about the rejoin function, but reduce, essentially what it does is takes in a block of data, evaluates any code in it, and then returns that as a new block. And I can just show you this. We will load up our red interpreter. load and evaluate our file, our program. Okay, something went wrong there, but and now I'm going to call this function. I'm going to do h1 and I'm going to pass it this, and let's see what the function returns. This is what it returns. All right, are you starting to see how this is all going to be working together magically? We'll do the same thing here for h2, for example. And by the way, in the red programming language, tags are first-class citizens, unlike many other programming languages. All right, so if we were to do this, I'm going to take out these here. Reload our file. What's going on there? I think the comment here is tripping things up. Let's try that. What is going on? Any numbered heading? Any unnumbered heading? Let's take this comment out of there completely. Let's stick it up here for now, because the only change I made was adding these comments. I think this is all fine. Let's try that again. Yeah, there we go. All right, so this is the result of parsing these couple lines of input, which is great. This is what we're expecting. And we're having parse collect this into a block and then returning the block, which is what we see here. And then we're binding that to, or making this word here point to that block. So if I were to do doc tree, it should give us the same thing. Now, as I just mentioned over here, reduce, what reduce does is it takes a block of data and then evaluates any code that might be in here. So do you see any code in here? That's right. H1 here has been defined as a function. H2 is also a function, as is H3. Each function taking in one parameter, so in this case H1 taking this, H2, etc. So if I were to call, in theory, if I were to call reduce on the doc tree, and if you remember, doc tree is basically just a pointer to this block of data, then what I would expect is, after this evaluation, is something that looks like this: H1 numbered 1, and then a closing tag followed by H2, and then another title here followed by the closing tag H2, and etc. Make sense? So let's just give that a try. Reduce doc tree. Look at that. So you see where we're going with this? All right, enough of that. I just wanted to expand a little bit more on the structure of our project and the different pieces. The front end, which is this parse function here. The back end, which is a code, I guess you could compare it to a code generator or a back end if you're familiar with compilers. And so these are the code generating functions. So let's jump into today's lesson, which is images. I'll try not to repeat myself too much as we go along. I'm assuming that you're a quick learner and trying things on your own. So I'm just going to go ahead, jump in and add a new rule here. I'm adding a rule for image. So now let's go here and define what the pattern for an image looks like. Essentially, it's going to be like this. And then maybe some spaces, at least one, some space. And then let's copy this down here. So that we can easily see the pattern. So image, some space, at least one space, could be more than one space, and then something right up to the new line here. And then we can just call that path to new line. Actually, what we want is to copy everything following the space right up to the new line and stick that into a variable called path. And then we are going to tell it to, once it hits the new line, just keep going through the new line, which will bring us to the next line of input. Make sense? Okay, so that's how you can express patterns. It's very, I love how easy it is to just convert your thinking process into code easily like this. It's very expressive, and you don't have to worry about too much about the, the implementation details so much. More so about how the trick is to learn how to describe things using this parse dialect and the keywords it provides to you. It feels very natural. So what we want to do is we want to keep, again, because the point here is that if we parse an image, I'm expecting to have something like this image, and then the path to the file. Something like this. And the idea being that there will be an equivalent function or a corresponding function, which we will name image, and we'll basically, do the transformation that we are looking for. In this case, something like, we'll have the function image return something like this. Image source equals, whatever the path is. I'll have to I'll have to check up on my HTML. I'm not sure if you need quotes here or whatever, but I mean, we can easily find that out like this. And if I remember correctly, maybe we need a closing tag. The details are not important. We can easily figure that out. So that's what we're trying to do here. Now let's give that a try. Back to our rule. This is the pattern, the word image, some space, and then whatever we find up to the new line, we'll just assume it's the file name or the path to the image. And then we want to load that up into our data block. So we'll say keep image, and then we will also say keep path. And I think that's all we need. So what we will do, I'm just going to do this as an example. We'll do another one. Image, it could be a relative path. Something like this. Well, before we get too adventurous, let's just make sure that this works. We will load up our file, run it, and look at that. Exactly what we were expecting. Isn't that amazing? Now, let's do a little bit of stressing the system. We'll mix and match some of these. Heading 1, maybe an image, and then maybe an unnumbered heading, level 2, an unnumbered level 2 heading, and then see what that gives us. Perfect. That's great. Now, as you can see, I mean, as we're giving it more input here, we're kind of losing some of the result of the evaluation that the interpreter is doing here. I mean, mostly because I'm using a half screen. So what I like to do is maybe save this to a file so it's easier to refer back to or to validate. So in red, there's a couple of commands we can use. We can say save, and this percent sign here basically means that whatever comes next is a file. So percent is basically used to differentiate between well, there's different literal syntax for referring to different data types, and in red programming language, a file is an actual data type, and the way to specify that is with a percentage sign. So we'll just say save to the file doctree.txt, whatever the file doctree, whatever we have in this variable doctree. We'll do that. I already have this here, so we'll have a look. So this is the result here. H1, level 1 heading, numbered heading, and then an image. Level 2 unnumbered heading. You know it's unnumbered because it has an asterisk. And then an image. Is there anything else here? No, that's it. Is there just one image? No, there are 2 images. Oh, yeah, there are 2 images here. So that's great. I think we'll wrap this lesson here today, right about here. Don't want to make it too long. I know my previous videos were a bit more lengthy, but you know, we're just going through stuff step by step, learning together, making sure we understand what we're doing, thinking things through, and that's how we roll. So we'll wrap this up now. In the next lesson, we will look at code blocks. That's it for now. See you next time.